Continuing our work on the Unit 2 review packet, we're going to go on with Topic 5. Identify the following as either inductive or deductive reasoning. Here we have 1, 2, 4. The next number in the pattern will be 8. Inductive reasoning is using a small sample in order to draw a generalization or a conclusion about a bigger group. Here we're looking at a small sample of numbers and we're trying to make a generalization or a conclusion about what we think the next number will be. That's inductive reasoning. Deductive reasoning, on the other hand, is using the laws of logic in order to come to a conclusion. This one says if you get this question right, you will pass the test. You get the question right, therefore you pass. This is the law of detachment. Because we're using the laws of logic, this would be an example of deductive reasoning. Give a counterexample for the following conjectures. A counterexample is a specific case where a conjecture is not true. Here we have all odd numbers are divisible by 5. To give a counterexample, we would have to name an odd number that's not divisible by 5. 7 would be an example. 7's not divisible by 5. That disproves this conjecture. It is an odd number, but it is not divisible by 5. In order to give a counterexample, you have to give a specific case where this is not true. It's not enough to just say something like, some odd numbers are not divisible by 5. You have to give a specific example. "18. All dogs have black fur." "Golden retrievers have golden fur." We gave an example of a dog that does not have black fur. And no, I'm not going to argue with you about that one golden retriever that's got a little bit of black fur on its paw or around its nose. They're golden. What does a counterexample demonstrate about a conjecture? Well, the whole purpose of providing a counterexample is to demonstrate that a conjecture is false. Here we gave a counterexample to show that not all dogs have black fur, so we're going to say it is false. Decide whether the following symbolic representations are correct. If not, correct the mistake. Law of syllogism. The law of syllogism in logic is like the transitive property in algebra. So this thing says if G to H, so I'll highlight G. Anywhere I see a G, I'll highlight it in yellow, make it a little easier to do it all in one pass. Here we have an H, so I'll highlight all my H's. And here we have an I. The transitive property allows you to chain together statements. So here we went from yellow to pink, and here we went from pink to blue. Well, the law of syllogism says, well, if I can go from yellow to pink, and then once I get to pink I can go to blue, then that means I should just be able to go from yellow straight to blue, or from G to I in this case. This conclusion, though, doesn't say I can go from G to I, it says I can go from G to H. So this is not the law of syllogism. Syllogism would take me here, cut out the middleman, and go to the end. So to fix this, I need to replace it with I. The law of detachment. If A, then B is true, and B is true, then A is true. With the law of detachment says if you have a conditional statement, if A, then B, and the hypothesis is true, A, then the conclusion B has to be true. That's not what this says. This one says B is true. If you take a look at our conditional statement over here, we have an arrow going from A to B. And what that tells us is, if I know A is true, I can follow that arrow to B, and I know B must be true as well. It does not point the other direction, meaning I can't go from B back to A because the arrow doesn't point that way. So here, knowing that B is true does not tell me that A is true. In order to fix this, I need to switch these things. If I know A is true, then B is true. Determine if a valid conclusion can be reached from the two statements. If it can, state it in the law that is used. If there is no valid conclusion, write no conclusion. 22. If a mineral is gypsum, then it has a hardness of 2. If a mineral has a hardness of 2, then it can be scratched with a fingernail. I'll start by highlighting the first hypothesis and first conclusion. It has a hardness of 2. The next one actually starts with the exact same conclusion we had last time. So highlight that in blue. A mineral has a hardness of 2. And then we get something new. It can be scratched with a fingernail. The law of syllogism is like the transitive property. So if I look at my statements, I'm going from yellow to blue and then blue to pink. Well, the law of syllogism says I can just cut out the middleman and go directly from yellow to pink because these two things link up with blue. So my conclusion would be, if a mineral is gypsum, then it can be scratched with a fingernail. For the law, that was syllogism. On both your quiz and your test, you were required to write in the symbols for that. Symbolic representation would be if P then Q, if Q then R, therefore P to R. 23. If it rains after school, then field hockey practice will be canceled. Practice is canceled. Hypothesis was it rains after school. Conclusion, field hockey practice will be canceled. And here I've got practice will be canceled again. This is the exact same mistake we saw in the law of detachment the first time, back in question 21, where it said from A to B and then gave us B. Knowing the second part of a conditional statement is true, the conclusion does not mean that the hypothesis is true. This is not the law of detachment because it tells us that practice has been canceled. Another way of thinking about it, practice could have been canceled for any number of reasons. Maybe the field caught on fire, or maybe something else happened. Conclusion? No conclusion. And because we didn't make a conclusion, there was no law that we used. Write a conditional statement or use the words all, sometimes, or never to write a statement about the following Venn diagrams. I will use the words all, sometimes, or never just because it's easier than writing a conditional statement. For 22, we can see that the pitcher's part of the Venn diagram is entirely contained inside the baseball player's part, which means that all pitchers have to belong to the baseball players category, which also means that all baseball players are also athletes. If we work it the other way, athletes has a portion outside of baseball players, which means that some athletes are baseball players and some are not. Same thing is true with baseball players and pitchers. Some baseball players are pitchers, some are not. I could pick any of those statements to write. I'll just choose all pitchers are baseball players. And you just put 3 dots to indicate that there's a lot more possible answers. Here we have things that taste good and things that are good for you, and they've got a little bit of overlap in the middle. Well, that means that some things that taste good are good for you, and some things that are good for you taste good. However, there are some things on the outside of which would taste good but not be good for you, or be good for you and not taste good. So we'll say some things that taste good are good for you. 24. Turtles and snakes are completely separate, which means that turtles and snakes have no overlap. They're never the same thing. Turtles are never snakes.